have us derive the formula, we are going to use this manipulative. Okay, this is a math device. As you can see, this is a circle. Okay? It's in a circle. And in this circle, this is the radius. And if you are going to measure, this is 10 centimeters. Okay, 10 centimeters. Yeah. Okay. And the radius of this is 10 centimeters also. You are going to try to check. The radius is 10 centimeters. Okay? Now, where is this pi r squared coming from? Assuming that we are going to subdivide it into the sectors, okay? The circle, and it looks like this. Well, this is one of the, this is half of the circle, okay? And if we're going to place like this, and we're going to place the other part, half of the circle, at the top portion, okay? Like this. Okay, since it is divided into sectors, it forms like triangles, small triangles. And after forming it or connecting them to two semicircles, we were able to arrive with this new figure, which looks like what kind of figure? Rectangle, which is an example of a parallelogram. And if it is a parallelogram, then we have the formula already, which is base times height. Okay. Now, if this is base times height, question is base times height. The area of this is base times height. What is the base? Okay. Since the base of this is this one, and we are going to relate it to the circle a while ago, before we divided it into sectors, this is the length of half of the circle, right? Okay. It means if we are going to combine the two bases, this one, base 1 and the base 2, if we are going to combine them, it will form a circle. It is the distance around the circle. And if it's the distance around the circle, like this, for example, this is a perfect circle, if it is the distance around the circle, it is what we call the circumference. Therefore, this one, this base plus the other base is equal to the circumference of the circle, which is equal to 2 pi r. Now, the question is, how about if we are just going to look for this, which is the base? Is it the distance around the circle or just half of the circle? The distance around the circle. It is half. Okay, right? Okay, so it is 1 half. So if it is 1 half, we are not going to use this 2 pi r. Instead, we are going to divide this 2 pi r by 2. So, because it is only half of the circumference. Therefore, 1 half of the circumference is equal to 2 divided by 2. We can cancel it out. It becomes pi r. Therefore, this base now becomes pi r. So if I'm going to draw this like this, okay, these are the sectors, assuming that this is this figure. This now becomes the pi r. Now the question is, how about this part? What is the measurement of this? This is the before we divide it, we divide it into sectors. What is this? What part of the circle? The radius. The radius. It is the radius, right? It's the radius because it is a distance from the center of the circle up to the point on the circle. Okay? So it is the radius. Therefore, if this is the radius, and we are going to use the area is equal to base times height, then we are going to replace the base with, what is the base? It is the pi r. So it is pi r, and the height is radius. This radius now becomes the height. I'm sorry. So it should be the radius is r. So if you are going to simplify, r times r is just equal to m times m, or meters times meters, which is meter squared. Therefore, this becomes pi, copy r, and then write an exponent to. It is pi r squared. Therefore, the area of a circle is equal to pi r squared, which is coming from base times height, and base times height is derived from this, the sectors, and this is half of the circumference, which is pi r, and this is the radius. So this is now our base, and this is our height, which is equal to the radius, and we have now the formula pi r squared. So that is the derivation.